Welcome to the Interop working group. I believe this is call number 5. We have a pretty solid and packed agenda today, which is great. I think we can get through it though, so we'll try to keep moving quickly. I've shared the agenda in the chat. I won't go through it all right now. Anyone have any questions, feel free to ask in the chat or just raise your hand, jump in. So let's just get started. First up on the agenda, we have Interopolis.
Hey, it's Helena from the Sprinter team. I don't know if you guys have heard or not, but we're organizing an interoperability on-site in Athens on May 22nd to 23rd. I think Dylan's on this call. He's actually the point of contact. So I'll let him jump in and add some info.
Yeah, hey guys. So yeah, like Helena was saying, we're gonna have a community on-site on the 22nd and 23rd in Athens. We're looking to do 4 tracks. We want to focus on general interop. So like we're looking maybe for just like 1 or possibly 2 of the tracks to be focused on L2 interop. But we have some pretty cool people involved already. We have a form to for anyone that's interested in becoming a facilitator or hosting a workshop. We're trying to focus everything on like whiteboard sessions, like no like panels or anything like that. Just somewhere that like everyone can kind of get away from the noise and focus on the work. So maybe Helena, you can drop the link for the brief in the, okay, cool. And in that brief, there's a form, see like just to gauge like the level of in how much you want to get involved in the sorry I'm on the road right now, but yeah, just write in the form if you want to get involved. So yeah, thanks. I think that's pretty much it. Thanks a lot, Josh, for also like putting together the planning group. We got some cool people that we've got on calls with already to get involved further. So yeah.
Awesome. Yeah, I'm excited for it. Thanks everyone from the Sprinter team for helping to push Interopolis forward. Anything else on Interopolis? Cool. Any questions? If not, maybe just reach out. There's a link in the chat. Thanks, Orest. And yeah, we can keep going to the next agenda item, which is interoperable addresses, formerly known as chain-specific addresses. So just a little bit of a rebrand potentially. Yeah, and I think we have Skelly here to share more.
Yeah, hey, can I get share screen permissions?
Yes, sorry, always forget.
No worries.
There you go, should be good.
Thanks. Okay. All good? Do you see the slideshow?
Yep, perfect.
Nice, awesome. Okay, so interoperable addresses. As Josh said, this is a small rebranding, cooler name, whatever. Chain-specific addresses was a bit of a weird name. So we've been working internally and on the public GitHub repo on this. Thanks for all the people that also contributed and commented on the PR and the current work. So we'll go as fast as we can through this. I know we have limited time, and this is a little bit of a technical presentation. So feel free we'll show this presentation afterwards, and you'll have all the information on the public GitHub repo. So don't go crazy if you don't follow everything here. We can always have an addendum call to go into more in-depth technical aspects of this if you guys want. So what we have today, as we know, is there's a lot of complexity in defining and addressing how, let's say, users are referenced on different chains. We have a lot of existing efforts, but we don't have yet, let's say, a unified vision on how all of these different efforts and requirements play well together. This is basically the motivation behind interoperable addresses, which is a revamp of an existing EIP. So what we have is what we want is to have a deterministic link between the actual name or what the user sees and what that name is referring to in both the chain ID and the address. We want to have as much flexibility as possible, both for defining these chain and addresses and also for defining the resolution to allow more modularity and neutrality when it comes to choosing which name service or resolver you're going to use. And the key goals for this were to basically, as most of the standards I will work with, is to erase kind of the ambiguity between having to choose one or the other, being, as I said, resolution agnostic. Very important point being future-proof. So we are introducing this concept of versions while still maintaining a machine-readable format that is shared across all of these versions. So always be kind of no breaking changes, backwards compatible versioning. So high-level concepts. This is the names that we're going to use for things. Interoperable addresses is the pair of address plus chain, and optionally a resolver specification, which also has its own address plus chain. The human readable names is what the resolver will output and what the user will see, plus a hash that indicates a checksum of the address plus chain pair. Then obviously we have the target, which is the actual address plus chain pair of the user or contract or whatever you're actually targeting. This does not include the resolver address and chain ID. And then we have the name resolver, which is we see the entity, for example, ENS or whatever, that is capable of basically translating this and showing the user what something understandable to read, not just 0x whatever. This basically trickles down to just these four fields: target chain ID, target address. Oops, we are adding an underscore there. Don't worry about that. And resolver chain ID, resolver address. As I said, the two last fields are optional. This is a practical example on how you would, let's say, construct this and how the user will see this. We have a specific chain ID, which is obviously short because we are using a specific standard for defining this, which we'll see in a bit. The address, the resolver chain ID, and the resolver address, which is, these are the contracts of ENS right now. The user will basically see that as we see below. Obviously, not with the colors, but they can also add the colors if they want. How does a contract or a computer see this? It's pretty straightforward. So here, do you see my mouse by any chance?
Yep, we can see it.
Oh, nice. Okay, awesome. This is going to make things a lot easier. So you have this, which is the version, like these first 2 bytes or 4 characters. Then this is the checksum. And then you will have some other fields that we'll go into later. This is the specification for which chain type we're going to use. This is obviously the number of the chain. This is something of the protocol that we'll see later. Address, same length of the message, same as the chain ID for the resolver, same for the address of the resolver. Pretty straightforward. As I said, don't go crazy about this. You will be able to see this in detail on GitHub, and if you want, we can do another more in-depth technical call. So this is the cool thing, right? So we have this kind of version in here, which will allow us to define different ways for messages to be digested. The main thing about this is that we always want message types to be, let's say, to not have any assumptions when defined, but then through assumptions be able to compress these messages and have these messages be shorter and more, let's say, efficient or less gas consuming or complex for either contracts to manage or whatever users to see or developers to see and handle. It's pretty straightforward. Obviously, I don't want to get super technical. So one of the points that we want to achieve is we know that contracts want, let's say, a canonical representation for, let's say, address chain ID pair. This is what we call version 8000. This 8 is the most significant bit, right? Then there is the space efficient version, which is just all zeroed out, which has the most significant bit turned off, or the let's say short version 1. And then this basically specifies if you're using a resolver or you're not using a resolver as well. And this is basically how we are defining a resolver, which right now, which is open to including different ERCs in the future. So this is super extensible. Okay, going to the specific example, right? This is how you would define, let's say, the shortest version of an interoperable address. Version 0000, which specifies, let's say, an EVM-specific short representation that has no resolver. So this is your checksum, which we can remove from here and just compute it on the fly for the user interface. But we are adding it here since it was previously in the spec, but we are not sure about this, so we love your input. Chain ID, oops, okay, I think we're missing a 1 here or whatever. And then the address. So this is 32 bytes, which most, let's say, applications that know that are only going to be interacting EVM to EVM can use today. Obviously, it has some drawbacks, which is you cannot specify chain IDs larger than this amount, which for the most part is okay, but it might change in the future. So if it changes, you need to go to the other version, like the long version, but it's all good. So this is basically what I said. We are only we are assuming all of these properties, right? So not supporting addresses longer than 20 bytes, not supporting chain IDs longer than 48 bytes, and only supporting this specific IP 155. So practically, in conclusion, the main things that we want to achieve is to always, as I said, I wanted to repeat this because this is the most important part. We need always a way to, from the canonical format, always kind of have a standardized way for not breaking the standard in the future as we continue to add new EIPs to handle different flavors of blockchains or whatever else that we would like to include for our, let's say, target specifications or name resolver specifications as well. Or if we want to extend this standard to add extra data on top of these two pairs of information. For example, I don't know, you can add payment information into an address, right? Like, hey, use this as a voucher, say, or as a receipt or a payment receipt for, hey, I need you to pay me, I don't know, 20 USD, right? So you can extend all of these through different messaging versions, but we're not going to discuss this right now. The main idea for this is to do a very, very simplified MVP for this, and then to build on top. So next steps. What we need from you guys, and this is super important, is community feedback. Special thanks to Frank here, which is, I think, the only one that is been reading and commenting on this all weeks and probably all days. So thank you so much. But we need more feedback from you guys. If you have any questions, if you need a specific technical deep dive, let us know. We can do that as well. We need to revamp the current ERC 7828 to interoperable addresses. The authors are okay with this. Obviously, we'll keep the credits and we don't care about that. We just want to at least keep the same number, which is a nice number. I like that number. We like that number. Just kind of revamp it a bit at these modifications. And after that, we'll work on a full technical specification. We are doing a bit of that on the actual GitHub repo, but we'll continue going into more like how libraries should work, how basically, yeah, how the entire system should behave with this and all the different types and different configurations. And then in parallel, we'll work on a specific wallet prototype for two things. One, mainly to test the UX of this and figure out what's the best way for the users to both see, add, or reference these addresses, and from the implementation side of things, how the wallet does actually find and basically digests these like interoperable addresses into the user format. A cool thing about this, which I didn't mention, but it's pretty nice, is that resolver contracts can actually specify how they are being resolved. So we are like kind of abstracting away the how resolvers behave into a different, like into their own thing, right? The standard doesn't say, oh, if you're a resolver, you need to behave, for example, as the ENS resolver behaves. You can actually define how your resolver behaves and have a specific module or library or whatever for wallets to interact with your specific resolvers. For example, a Solana resolver or a whatever different resolver, DNS, etc., etc. So that's basically it. Go into the GitHub repo. We have PRs that we are going to be merging very, very soon. If not, go into the PR and see the current work. Thank you so much.
Awesome. Thank you, Skelly. Any questions?
What is the best place for feedback and discussion?
Definitely GitHub.
So would that be an issue or?
It can be an
PR.
issue, or it can be comments on the current PRs. As we're going to be merging them soon, yeah, I suggest going to PRs, checking the current work, and after merging, probably an issue is best. Or if you haven't already, let's say, a different proposal, doing a PR with your different implementation or ideas also works perfectly fine. Oh, and you said, can you repeat the open question about the checksums? Yeah, so checksums are now enshrined, let's say, on the memory representation, but that's not necessarily, because if we know how to compute checksums, we don't necessarily need to add them as part of the message. We can just compute them and show them to the users. So that's the open question.
Cool. All right. Next up, we have a quick update on the, excuse me, on the open intents framework. So yeah, this will just be a quick update on the OIF. Over the past few weeks, we've been having some discussions focused on, I guess, making sure that we have the best possible initial foundation for the OIF. Before we double down on what we're building and on top of that foundation. And this initial foundation, I guess what I'm calling the V1, is great. Huge thanks to everyone who worked on that, in particular the Bootnode team, Hyperlane, and others for putting out something that's high quality and helping to set the initial vision for all of this. But I think we've also realized that there's an opportunity to set an even stronger initial foundation and incorporate some learnings from the past few weeks. So with that all in mind, we've been discussing what a OIF 2.0 would look like. And the group of us have just been sort of informally doing some initial design, brainstorming, planning around that. This includes, of course, Hyperlane across Bootnode, but also LeFi, OpenZeppelin, and the Wonderland team. LeFi and OpenZeppelin are a bit newer to the group of the OIF, but are definitely not new at all, of course, when it comes to these sorts of design considerations, interop related work. So very excited to just sort of unify these efforts together and have it all be a part of this OIF 2.0. I don't want to over-index on sort of like the marketing and branding of this OIF 2.0. I mean, there is a little bit of branding there, I suppose, but it's really more about just making sure we have the best possible thing here, the best possible solution, and less about like a big splashy, hey, we have an OIF 2.0 thing. I think there's a balance of both, but yeah, trying to get back to actually shipping something here. Um, yeah, so I guess just consider this an open call to anyone else who would like to get more involved in this OIF 2.0. Last thing I'd say is the goal of the OIF is unchanged, which is modular deployment of fast bridging infra to all chains. This includes intents, of course, but also resource locks and just generally solving infra, solving infra and all this good stuff to all chains. So if any questions, let me know. Just want to share this quick update. Still a lot for us to figure out here, of course. Don't want to oversell what we have, but it is. I do think it's been great to see the progress, and yeah, we'll of course share updates to keep everyone here in the loop as we continue to make more progress on this. Cool. If no questions or feedback. Alrighty, sounds good. We can keep going.
I have
yeah.
one quick
Yeah.
question.
Sure.
Are there any like specific changes that are being anticipated as part of this 2.0, or like modifications to the foundational tech, or is it primarily just bringing in a couple new projects to the team?
Yeah, it's good. Yeah, good question. Definitely some meaningful updates and improvements. Might be a little bit early to get into specifics unless anyone from Open Zeppelin or LeFi wants to share. I think, the truth is that these are still decisions that we're trying to sort of sort through. But yeah, maybe Jem here can add something. I think you're muted, Jim, if you're talking, or we can't hear you. Still can't hear. Can anyone else hear Jim? Is it just me?
Can't hear.
Okay. Yeah, some kind of mic issue, Jim. Now you're frozen.
Yeah, Jim looks frozen now. Zero, what I just say is like we've shared like some things we think are gaps in ERC 7683 with Open Zeppelin. Just really like how do you standardize the settlement layer? This is something that I think is probably better done asynchronously, but it's just really looking at like what do we think are the gaps of actually like scaling this and making it go everywhere, and then trying to build a 2.0 version that fills it. That'd be my 2 cents.
Good.
Yeah, maybe
Go ahead,
to add, I think I would view it a bit like as two goals. Actually, one is that, right, and then two, I think maybe Zero, you're referencing to, right, like our ongoing work with like having a like OIF reference solver be able to support not just like intent protocol implementations in the OIF, but also other things like the compact. And so certainly it is of our interest to ensure basically that migration path for like basically for like a reference solver working well. I think that's arguably the biggest demand that we've seen for OIF 1.0, and I would be foolish to like kind of like forgo that for the 2.0 version as well. And so definitely part of those conversations are to kind of like maintain kind of that value prop for folks like you.
Yeah, you guys hear me now, by the way? New laptop, so permissions and shit are funky. Cool. So I would say like the meta, like I guess improvements of this new OIF like proposal or framework is that like we saw the V1 of the OIF repo, and I think broadly the feedback was that it wasn't comprehensive enough. I think people wanted to see where potentially resource logs fit in, where other verification methods could fit in that weren't messaging protocols like proof layers, where off-chain auctions could fit in. Nam brought up different solver implementations, Hart brought up the settlement layers. And so just having like a very comprehensive view of that. So anyone who's working on different layers that can contribute that to basically just like a full menu of things that anyone could use if they want to be building a bridge for their new chain.
super down with this. Sounds great.
Cool. Anything else on the OIF 2.0? Yeah, looks nice where you are at 0 age. Cool. Okay, next up, I am going to share a work in progress roadmap diagram that I've been sort of jamming on in collaboration with a few other folks. Would love to get some feedback. This idea here is just to sort of share what we have as a work in progress. Hopefully we'll continue to refine it over the coming weeks. I'm sure we will. But again, just sort of an open call to anyone that would like to provide more feedback on this document. Let me share my screen. Sorry, 1 second. Find the right screen. Cool. Can you all see this diagram?
Yep.
Cool, thanks. So let me know if any questions, anything, just feel free to jump in. If any questions, anything is unclear here. The idea is to sort of summarize at a high level where we are and where we're going. As you can tell, based on where I'm showing this, this is still sort of just a work in progress diagram here. Still need to make it a bit prettier and more complete. But yeah, summarizing at the top, the goal: fast, easy, trust minimized movement of assets across any chain in the Ethereum ecosystem, and separating it out here over the next 6 to 12 months in sort of 3 to 6 month chunks, just to kind of give some structure to things and hopefully hold us, timelines are tough, but hopefully hold us and myself accountable to continuing to make progress and move things forward in a meaningful way for our users. So zooming in here on months 1 to 3, standardization and wallet work, I guess is sort of how I'm defining it or framing it. A lot of these things are things that I think we're already familiar with. 7828, we just went through, interoperable addresses, the OIF, 7856, chain-specific payment requests. This is something that Jack from Base has been kindly pushing forward. We may have more to share on that soon. Cross-chain messaging. We have had a separate group on this for a while now, trying to consolidate the handful of sort of related and overlapping ERCs on this topic. 7755, again, Base team and cross-chain calls. 7785, moving chain ID registration on chain versus the sort of current today being on a centralized GitHub list. Lots of benefits to doing so, of course. And then last up in this sort of next months 1 to 3, this experimental wallet prototype that I've been sort of that we've all been discussing and teasing for a little while now, and we'll be starting work on soon. I'll have more to share. I know we sort of just keep sharing that this wallet will be starting soon, but for anyone that's not aware, the idea is not that this is a full-fledged wallet. The idea is that this is a very experimental sort of proof of concept, perhaps testnet only, to actually get these interop features into people's hands, let them play around with it. Things like interoperable addresses and the OIF, and actually show, hopefully sort of to pave the way a bit in terms of what these things can look like from the UX side. So that's the idea with the wallet and the first 3 months. As we get down here to these sort of second buckets, months 3 to 6 and 6 to 12, I think there's much more less certainty around what things make sense here and what we should be prioritizing. So again, this is sort of a call for the group here to provide their input. Some of these things that you'll see in months 3 to 6 and 6 to 12 are a bit more exploratory. This idea of shared bridge, which I think actually Mohammed may be in the group here. He's presented a really great workshop on back near the end of last year in Bangkok. I think it's certainly an area that's worth more exploration. And other things here, some of these things I think we do have more confidence that we should be prioritizing, or maybe not huge effort. It's more sort of a coordination thing, but L1S load as another example. and then just continuing to work on the wallet prototype and actually at this shipping some version of cross-chain transactions. Last up, I'll just go through this quickly. Again, just more exploration. What are other things that we can do to actually ship seamless cross-chain interactions, get these things into the hands of users? Yeah, I don't have a lot more to share right now, and very open to more feedback on what people would like to see in these buckets. So yeah, that's pretty much it. Just wanted to kind of walk people through that right now, and happy to take any questions if there are any. Cool. Sounds like no questions. So then we can keep moving. Oop, next up on the agenda, we have the Open Intents Framework / Espresso Hackathon. I think we have Jill here.
Hey, yeah, great to be here. Thanks so much, Josh. Let me share my screen. Let's see. Can you all see this slide deck I'm now presenting?
Yep.
Okay. Yeah, I'm a Google Meets gal. I'm not used to Zoom. Great. So yeah, this is a little bit of a misnomer. It's really an espresso hackathon, but there is an open intense track to it. And I think it's one of the first developer initiatives since this working group got going that's taking the form of a hackathon. So I'm just going to share some of the lessons that we've learned along the way so far. We're halfway through the hackathon period and we'll have more to come. So yeah, I'll share first some context and motivations behind us running this hackathon, some of the details, the progress, and then where I'll try and spend most of the time is on kind of the challenges and insights that we've had so far and what we see as some of the possibilities and next steps for making the open intents framework more real for developers. For those who don't know, I think most of you probably know, but we're consensus protocol for cross-chain confirmations. You can think of us as a more secure alternative to pre-confirmations. We sometimes call ourselves an L1.5 or confirmation layer because we sit kind of between the L2s and the L1s. And whatever, this is the team. We've got about 20 chains in the process of integrating. And to date, we've been mostly a B2B company. Like we've spent most of our time and our cycles on the go-to-market side talking to chains that already exist. But we are looking beyond that now to work towards onboarding developers to build and deploy their own chains, specifically right now using the Arbitrum Orbit stack. And then, of course, using Espresso for confirmation. So there's a lot of great examples of teams that have gotten folks up and running, building their own chains. Of course, all of the core stacks like Arbitrum. We've also taken a lot of inspiration from OP's developer experience. Your docs are chef's kiss if there's anyone from OP on here. Celestia, of course, has a great track record of this stuff in their hackathons and with the Rollkit project. Eigen hackathons are incredible as well. So a lot of great playbooks that we're drawing from here. And we're trying to get developers ultimately to build more cross-chain applications. So, you know, some of the examples that we came up with were like a cross-chain NFT marketplace, cross-chain borrowing and lending. These are all things that are top of mind for us. And then the other goal of the hackathon, of course, is just to get developers educated on how Interop works in general, and then, you know, selfishly, specifically Espresso. So this is the QR code. If you want to go to the website, you can feel free to grab this now. And again, the hackathon is running for this month. It's got 2 tracks to it. So the first track is just getting people up and running and deploying chains, again, using the Arbitrum Orbit stack and using Espresso. And then the second track is really where the open intents side of it comes in. So this is kind of like the bonus round of, okay, now you've got some chains up and running. Let's actually build something across 2 of them or 3 of them or whatever. And we have recruited some great partners to this hackathon. I think that this has been a huge part of whatever success we've had so far has been the involvement of Hyperlane across OpenZeppelin and Bootnode. This came about like somewhat organically. We just shared what we were doing and folks from all of these teams reached out, and super, super grateful for your collaboration. We've gotten really great feedback from the developer community that we're corralling together on the collaboration with all of you guys. If there's anyone else here who's interested in getting involved, even at this kind of later stage of the game, or who would like to collaborate on these types of things in future, we would love that. I've mentioned a few times our main integration partner right now is Arbitrum, so it's the Arbitrum Orbit stack. We're also working with Infura and AWS. And it's going pretty well so far. Like we've got, as of today, 266 devs signed up, truly globally. We did a lot of work customizing our tweets and our developer push for all of these different regions, and it's paying off so far. So that's exciting to see really global participation. And again, a good number of devs signed up. This is our first developer initiative, so we don't really have a base to build off of. So decently happy with this so far. We got about 4,000 people tuned into the workshop that we hosted alongside Hyperlane across OpenZeppelin and Bootnode. And again, had really great feedback on the workshops. People found them really, really helpful. And then we've had about 20 developers attending the first couple of office hours that we've run. Okay, now for the more kind of interesting parts of this. Some of this I'm sure will be old hat to those of you who've done developer initiatives before, but we found that it's been really key for us to tap into existing developer communities. ETH Global, College DAO, and Developer DAO, and then since Arbitrum is our stack partner on this, like they've all been really, really key. But what we're finding is that all of these developer communities are full of smart contract developers, but really actually not that many who are deep on blockchain architectures, let alone the specifics of interop and intents. And my colleague Mariana, who's the one actually kind of running the hackathon, she pulled this stat that we've got about 600 million smart contracts deployed. I think that this is just EVM, maybe it's across all VMs, but relative to the number of actual chains deployed or rollups deployed, that number is way, way bigger, right? We're looking at maybe 1,000 chains deployed or in process of being deployed in the Ethereum ecosystem. So the community of developers who we can target here without like a massive onboarding lift is still pretty small. And then again, there's even fewer developers who have a lot of context on interop and intents and are sort of prepared to dive in for a few day long or a week long effort on a hackathon basis to be able to build something real with the tool sets that we're giving them. So that's been a major challenge, and again, a major insight. Again, my colleague Mariana, who's running DevRel and growth, she put together this slide, which I think is really great just for the intuition behind this, which is, okay, we've got this big wide world of Web 2 devs, and then we've got a much smaller world of Web 3 devs. And within that, the lion's share are smart contract devs. And like, that's where they're coming from, and that's what they're thinking about. And so as we think about growing the pie of developers who can be building cross-chain and can be building with intents, like we've really got to think about how we are doing education and onboarding. And, that encompasses both finding where to reach people, like who are the right people to pull into this. Of course, ultimately, we want to be growing the pie to encompass more Web 2 devs and pull them into the infra side of this. But maybe the right place to start is with the folks who are already familiar with blockchains just from the perspective of smart contract engineering and pull them over to the infra side. I think that there's a lot of kind of interesting like developer relations and marketing funnel kind of questions here. And then of course, as well, we just want to be thinking about how are we ramping up those who maybe have already some context and curiosity on the infra side, to get them building real things and then support them going forward into the future. So, some of the next steps that we've talked about just internally, again, we're only halfway through the period of the hackathon, but is just creating more developer resources. We did this series of workshops the other day with Across and Hyperlane, Bootnode, and OpenZeppelin. Can we help promote the discoverability of those workshops? We don't even necessarily want to just own these resources as a repository with espresso behind it. Like, we want this to be kind of more of a community driven effort. So, be happy to contribute those workshops to kind of like the OIF overall information and resource hub. Or can we do more of this as a group, recording workshops, walking through each of our projects, documentation, linking it back to ideas for cross-chain applications we'd all like to see built, and help kind of cross-promote each other's work in that way. And then also continuing to work on and promote our own documentation, each other's documentation. One cool idea that Mariana had was to consider at some point the creation of almost like an Interop startup school. Probably many of you are familiar with the crypto startup school that A16Z runs, where it's, I think it started as like more or less kind of like a hackathon type of experience, but then of course you also get a lot of input onto how to think about business model, how to build the company, all of these types of things. So again, making sure that we're really capturing the developers who we onboard into building it in an infra and building cross-chain, to promote them and make sure that, they have the support they need to take the next steps and take the projects forward. And then lastly, we will definitely follow up with more of the actual data that we've collected through the process and further insights when we have them in April as we wrap up the hackathon. We're really excited so far about some of the projects that we've heard getting built, but obviously it's still early days, nothing has been submitted yet. So we'll know a lot more in April, and we'll be thrilled to share more then. In case you missed it, here's that QR code again. You're welcome to go to the site. We have a whole list of ideas to build, and we have a bunch more details on how we're running the hackathon. But again, I just want to give a huge shout out to this group, and especially Hyperlane, Across, Bootnode, OpenZeppelin. You guys have been amazing partners so far. And if anyone wants to get involved who's not currently either in this or in a future project, please let us know. But it's definitely, to me and to Mariana, again, who I give full credit for running this whole thing, it's definitely been a huge lesson so far, just in how much opportunity there is to bring cross-chain and bring blockchain infra to developers overall. And then it's also been a huge lesson in just the power of having multiple projects banding together on these things. Definitely owe a lot of the success so far to those of you who've jumped in. So thank you. If there are any questions, I'm happy to take them. Mariana is also on here. She's probably even better to answer questions. But, I see there's been a bunch of questions in the chat. Maybe.
Thanks, Jill.
Want to jump in live to have conversation? Or?
Since we're a little bit running short on time, maybe we can move the Q&A to async. Is that cool, Jill?
Yeah, that sounds great. Thank you, guys.
Thanks, Jill. That's great. Cool. Next up, 7755 updates from Jack.
Awesome. Yeah. Here is a link to a little demo app we deployed for anyone to play around with. And then I'm going to go ahead and share my screen. Let's see. All right. I assume you guys can see this.
Yep. Perfect.
Okay. So yeah. Hey, everyone. I'm Jack. I've been driving forward the progress on 7755 for the last handful of months. So I'm going to give a quick update today It is, first update, it's now RRC 7755. It's previously known as RIP 7755. It's been categorized as a rollup request for comment. So just as a little, I guess, FYI, it's like an ERC, but for rollups, and that's how it'll be referred to moving forward. Some quick background for anyone who's not familiar. It's a standard for cross-chain calls in the Ethereum ecosystem, but is defined or implemented in a way to like leave open support in the future for non-EVM chains, or the possibility for support for non-EVM chains in the future. The architecture is similar to a lot of the intent protocols that the ecosystem is becoming familiar with today. It relies on three main components. There are contracts for message passing. It relies on off-chain fulfillers for relaying messages to destination chains on behalf of users. And then there's a settlement layer for verifying call delivery as a precursor to fulfiller compensation. And so the architecture is diagrammed here. You can see just like really quick, user for a happy path, user submits a request to a source chain outbox contract with compensation for the fulfiller included. The outbox contract then notifies or alerts a fulfiller network by emitting an event. If the request makes sense, fulfiller submits the call plus any funds needed for call execution on a destination chain inbox contract. And the inbox contract acts as a router, executing the calls to their specified destinations. And if all are successful, it creates an execution receipt that gets stored in storage in an immutable fashion that cannot be updated or deleted in the future, barring any kind of chain reorg, of course. And the existence of this receipt is used as the target of a storage proof that the fulfiller can then generate after a delay, submit that back to the source chain outbox, and if the proof checks out, the outbox releases compensation to the fulfiller. And this is made possible by state sharing between rollups and Ethereum mainnet. So it's possible because if the source chain has an L1 state representation exposed in its execution environment, you can prove something about the state of L1. And if the destination is posting its state representation to L1, you can prove that and then subsequently prove something about the state of destination chain. So that's kind of high level how it's working. If you want to dive in deeper, I invite you to read the proposal. So latest progress, we have contracts deployed to test networks for Base Sepolia, Optimism Sepolia, and Arbitrum Sepolia. And all possible routes between those three chains have been successfully tested end to end. So I guess my main update is it works, which is cool. The contracts have gone through an internal audit already and are in a pretty good state. In order to get it to this point to work, we had to implement three storage proof verification, I guess, on-chain mechanisms. One is for OP stack chains based on finalized state. One is for Arbitrum chains based on finalized state. And then we got a contribution from the cross-chain alliance team of a Hashi prover, which relies on block header sharing from their Oracle aggregation network called Hashi. So that'll be really helpful for adding support for non-EVM chains in the future. If desired. Also spent a lot of time in recent months working on adding smart account support out of the box, specifically ERC 4337 smart accounts. I have more information on that on the next slide, so I'll talk more about it in a minute, but the standard now supports relaying user ops for the destination chain on behalf of smart accounts, which is pretty cool. And then lastly, I added deployed a demo app that I pasted the link to in the chat. Feel free to play around with it. It's not meant to be from the perspective of the end user where, like, for example, if you're trying to bridge ETH, you just hit send and then it magically shows up on the destination chain. It's purposely set up to be tedious and like segmented step by step, just so like you can get a visualization of exactly all the steps that need to happen in order for that to work out with the system. It's very much meant to be like developer oriented. So just to take a slightly deeper dive on the account abstraction support, a concern was raised back at DevCon in Thailand that the architecture I went over a couple slides ago doesn't support permissioned calls. So like if the call target relies on message.sender based authentication and the sender needs to be like the requester in that case, then that wouldn't work. And so you can get around that by submitting a user op to the destination chain, and that's what's depicted here. So instead of submitting the request to the destination chain inbox contract, a fulfiller could then submit a user op to the destination chain entry point, And then there's a whole bunch of 4337 infrastructure deployed and like widely accepted on many chains, as far as I'm aware, that can be reused here. And that allows us to route the calls directly through smart accounts and get around that permissioned issue. And so, yeah, that solves that issue. But then if that's the extent of the implementation, then you run into the problem where the smart account needs to be funded for gas and any funds needed for call execution. And that kind of goes against one of the built-in invariants of the system, where the fulfiller should be the one fronting gas and call execution funds. So we introduced a paymaster support directly into the specification of the system that originally we were going to make the inbox contract the paymaster, but because of the fact the inbox contract routes arbitrary calls for like the regular request flow, it seemed like a fairly big security issue to have it holding funds for paymaster support. So ultimately decided to separate that into its own contract that is owned by the inbox, and the paymaster like hooks into the regular 4337 flow. In that it is holding pre-deposited funds on behalf of fulfillers and keeping track of allocations of those funds between the fulfillers. And if, like, because of the fact the fulfiller is the one submitting the call to the entry point, from the context of the paymaster, that's the transaction origin. And so that's kind of like built-in authorization to spend the funds, just by nature of the fact that, yeah, the fulfiller is the one submitting the call. So really all the paymaster has to do is ensure the fulfiller has pre-deposited enough gas and call execution funds in order for this to like work out. Everything else about the 4337 flow should work as expected. After the calls are executed, the entry point then calls back into the paymaster with a post-op call. And one of the input arguments here is like the call execution like result, if it was successful or not. So that allows the paymaster to then generate the receipt or execution receipt in the inbox storage only if the calls were successful, to uphold that same invariant that we went through in the previous architecture diagram. And this can be done securely because of the fact that the paymaster is owned by the inbox contract. So these two addresses are aware of each other. So looking ahead, that's kind of where things are right now. We are at this a little bit of an inflection point where the contracts are in a pretty good state. I think this system has some pretty attractive qualities and a good combination of qualities. And they have passed an internal audit. And now there's a handful of questions that we have to clarify to determine if it makes sense to move forward with an external audit and like deploying this thing on mainnet. To go through some of the properties, like I think the system has obviously an interesting proof system with storage proofs. I think it's expressive in that it allows arbitrary call execution on destination chains and any batch of calls at that. It's also permissionless, like anyone can submit requests to the source chain, outbox contract, anyone can run fulfillers. There's no contract owners in the system. It supports permission calls, as I went through on the previous slide. And it's pretty good with latency as well. It can submit calls in like 1 to 3 seconds, like from call request to call fulfillment on destination chain. It's largely dependent on the block time of source and destination chains like that are like relevant for the request. So I think it's a compelling group of properties, but there's also many other interop protocols that are very good on most of these properties as well. I think the two that maybe set 7755 apart are the combination of the proof system and support for permissioned calls out of the box. And I guess the question is that enough to justify continuing to push forward on the development of its own standard? Or are surrounding interop projects mostly just interested in like using a storage proof utility library and like we can extract attractive properties out of this 7755 proof of concept, but existing interop protocols already have enough of the properties that like maybe plugging in different properties from here makes more sense. So that's kind of where we're at, still trying to think through all of the different, I guess, factors here. But if anyone has comments or opinions on that, I would love to hear from you. Maybe doesn't make sense on this call just because I know we're running low on time, but I'll be around on Telegram and would love to chat about it. I think regardless on what gets decided, there will be a fair bit of effort the next couple of weeks updating documentation. And releasing blog posts just to spread more awareness and education about the system, as like it has come a long way from when it was first started. The official proposal was updated last week, so if anyone goes to read the 7755 proposal on the RIP's repo, you will be seeing updated information. So definitely check that out if you want to read more. And I think that's all I got for today. So thanks for your time.
Awesome. Thank you, Jack. Cool. Last up, I guess I will say for any further discussion, async, maybe we can move that to the Telegram group, or Jack, if you have a preference for where you'd want that discussion to go, maybe just drop a message here in the chat. Cool. Last up, we have a 7683 demo from the Omni team.
All right, are you guys able to see the screen?
We can.
Awesome. All right, so Omni's working on an ERC 7683 compliant generalized intent system that does more than just swaps or transfers. It, in theory, will allow pretty much any cross-chain call to be conducted. So what is Omni real quick? We're just a protocol that basically allows you to build a cross-chain dApp, but deploy it to a single chain and access users from anywhere using intents. Because it's very easy to build a cross-chain app, but all of the embedded interoperability solutions is where all the complexity comes from, and this causes problems and delays for on-chain applications. So Omni is aiming to solve this problem through an ERC 7683 compliant smart contract system that allows apps and users to submit intents, a network of solvers to go and fulfill it, and our own independent cross-chain messaging protocol that relays that fulfillment. All of this is tied together by an SDK that just makes it very easy to use. So for this example, we'll debut a cross-chain deposit into a vault. Our quote system is fairly straightforward. In our SDK, you just specify the source and destination chains. In the expense, you'll basically, so say the user is depositing 0.01 ETH and they need to know exactly how much they're going to get on the destination. They can quote for an expense, and vice versa. If they want to get exactly 0.1 ETH on the destination, they can quote for the deposit, which is what you're seeing here, a quote for a deposit expense. And then once you have that quote, you basically just retrieve those amounts for the deposit and the expense, package it into an order like so, again, with the source and destination chains, context about the deposits on the source, the expenses expected on the destination, and the call being requested with its ABI and parameters and target address. Once this is issued, this cross-chain fulfillment will take place. Because we're just ERC 7683 compliant, we have our own order data packing. This is what that looks like. We basically allow the user to specify who the order is for, what destination chain, and tightly packed information about the deposit, expense, and call structure. And just in case there are any questions about this, we have separated the selector so that we could maximize space utilization here, because each parameter is only 32 bytes, basically, once ABI encoded. And if we had that selector, it would needlessly take up another slot. So we've gone through and basically gas optimized this to try and make on-chain intents as cheap and efficient as possible. And then we even have the ability to filter based off order status. So using the SDK, you can see from start to finish where an order is in its life cycle. We have a bunch of links here. I will share these in the chat right after the demo, but let's head over to the demo. Let me blow this up a little more. So in this little basic demo front end that we've built, we've got a mock symbiotic vault. They're a restaking protocol in the Ethereum layer 1, and I'm connected on base Sepolia. So I'm going to deposit 0.01 wrap stake ETH into symbiotic. We've got our mock on Wholesky. We're basically quoting for the expense here. So my deposit's going to have 30 bips removed and will be deposited in kind. We'll open that up and submit it. All right, so the order gets submitted. Our solvers are going to go and fulfill this order. And upon inclusion, we'll see the transaction on the destination here. Just waiting for it to complete. There we go. Let's open up the deposit. Hopefully we get the fulfillment here soon. There we go. And then we can see that my address called the open function deposited in 0.01 wrap stake ETH. This happened at 5:01:16. We're still not indexed on the destination yet. There we go. And we can see the fill took place. It deposited in the amount of wrap stake ETH necessary and deposited that into the vault. We were able to get this cross-chain call from base Sepolia over to Ethereum Whole Sky in about 8 seconds, it looks like. But this is highly variable. It has to do with layer 1s and layer 2s. Layer 2 to layer 2 is obviously even faster. But yeah, that's basically a basic quick demo. We also have cross-chain bridging. I could bridge over a little ETH from base Sepolia over to Arbitrum, but I do recognize that we are out of time basically. So if anyone has any questions, feel free to share those questions. Where did my Zoom chat go? Oh, I can't see it while presenting. But yeah, that's basically it. We are excited to start bringing this forward. We have some public testnet launch partners here soon, one of which notably is Symbiotic. And then we have a couple other partners that we've been talking to and interacting with and building this out for. So we are excited to bring it to mainnet shortly. Everything has been deployed on mainnet. All of our contracts are open source. We build everything that we do completely in public. So I will go and share the links to our docs, our website, and our contracts and solver implementation in the comments for everybody.
This is great. Thanks so much. And yeah, sorry to squeeze you in at the end. Thanks for doing it quickly.
No worries, no worries. We're excited to also start exploring the open intent framework now that our solution has basically come to market. We're at a point now where things are becoming actionable and ready. So we feel that it's now a good time to start contributing to that discussion as well.
That's great. Yeah, looking forward to that. Cool. Well, we can end there. Thanks everybody for being here again. I know we all have lots of calls every week. Appreciate everybody making time, and we will talk again soon. Thanks all.
Thanks.
Thank you.
Bye bye.
Thank you.
Thank you.
Thanks, guys.